Good morning, everybody. Yesterday we talked about solving linear equations. We did that by following the rules of what we do to one side, we do to the other. The same will apply today, obviously, because that's how we solve equations. However, it is possible to get an answer that does not have a number. Sometimes our answer is another equation. Here's an example of that. The formula for the perimeter of a parallelogram is 2 times a plus 2 times b, where a and b represent the measure of the bases. So here's our base, here's our base. Solve the equation for b. What it means to solve for b is they want us to focus on b and get b alone. Sure, there are other variables. We're not going to get a number answer. We'll actually get an equation as an answer, but we are going to solve for b. So I start off with my equation. And again, if my goal is to get b alone, I want to get rid of everything else on the same side of the equal sign that is not part of b, or that is not b. So the first thing I see is that I have an added 2a. To get rid of an added 2a, I want to subtract 2a. Again, a lot of people might say that they want to divide by 2, but we're not just trying to get rid of the 2 so a is alone, we're trying to get rid of the entire term. So I'm going to subtract 2a. What I do to the right side of the equal sign, I also need to do on the left side. That leaves me at p minus 2a is equal to 2b. Now, b is almost alone. My final step is to get rid of that 2. That 2 is multiplying b, so I divide by 2. Whatever I do to one side, I do to the entire other side. So I can kind of distribute a dividing by 2. Our 2's on this side cancel out, and I will write my equation in blue on the inside. B, actually let me keep it in the same order. I'll do B on this side. B is equal to P over 2 minus 2A over 2. Again, when the bottom, or when the top has plus and minus of a fraction, we are allowed to break it into multiple fractions. It is not true, however, if your plus or minus is in the denominator or the bottom. However, since I don't see any pluses or minuses in the bottom, I'm free to go ahead and separate my fraction. P over 2 cannot be simplified, but I do see that there is a 2 in the top and the bottom of this one. So these 2's would cancel out, and realistically, 2 divided by 2 is 1. This would just be a. So P over 2 minus a is equal to b. We have an equation for b. We've solved for b. All right. So the next thing I want to talk about is when we have graphs involved in the mix. How can we use graphs to solve? So for some people, since graphs are visual, it is easier for them. Some aspects of graphs make it harder. However, graphs are usable to answer questions. So again, to reiterate, the solution of an equation is called a root. You can find the root of an equation by examining the graph of its related function. A related function is found by solving the equation for 0 and then replacing the 0 with f of x. So here's an example of that. 2x plus 13 equals 9. I need one of my sides to equal 0 according to this, so I would subtract 9 from both sides. And I would get that these cancel out and become 0. 13 minus 9 would become 4, and that's how we get 2x plus 4. So we would have 0 equals 2x plus 4. But again, oops, I was about to write out the word 4. Don't want to do that. But then we replace the 0 with f of x. And there we have our related function. Remember that f of x is the same thing as y. So these two are saying the same thing. F of x is just called function notation, whereas this is just our equation using y. All right. So values of x for which f of x equals 0 are called zeros. These are going to look like x-intercepts. So if I take a look at this and I set 2x plus 4 equal to 0, I can start solving. I want to solve for x, so I subtract 4 from both sides, and then divide both sides by 2, and I get that x is equal to -2. That's how they are getting these. So -2 is the solution to this, the original equation. -2 is the root of this as well, because again, roots and solutions are synonyms. -2 is the 0 of our function notation. Again, since -2 was the answer, when we set it equal to 0, -2 is called the 0. And -2, since it is a 0, will be the x-intercept of our graph, which we can see right here. So our graph can be used to find zeros, it can be used to find intercepts, it can be used to find certain values, as we've seen with graphs. All right, so if we take a look at this equation, it says solve it by graphing. First, we find the related function, meaning we want one side to equal 0. In order to do that, we need to get rid of this -8 by adding 8 to both sides. And when we do that, we get 1/2 x minus 3 equals 0. So our related function is f of x equals 1/2 x minus 3. Now that we have that, we can graph it. Again, looking at this tells me that my y-intercept is -3. So I'm going to put a dot at -3 once I scroll further down. And the 1/2 tells me my rise is 1 and my run is 2. That is my slope. So I'm going to put a point down at, get out of here, -3. And to rise, I should rise 1 and run 2. That's what a slope of 1/2 means. Oh, it isn't like that. Okay. And then I will connect these two dots. And there we have my line. Try zooming out, see if that works. Okay. So it's asking for the solution or the root. When does it equal 0? Well, it looks like it meets 0 at this point on the line right here. This says that it is 6, 0, where we touch, right here. So this point is at 6, 0. Therefore, the solution to my problem, the answer that caused it to equal 0, it intersects the x-axis at 6. The solution of the equation, therefore, is 6. Okay, so there are more examples for you that you can work on. We can also estimate solutions by graphing, look at where it's between to find out where the answer is. But your work is posted on ConnectEd. It was there yesterday. If you started it and finished it, great. If not, you should be working on it. So your work today is that we are on 2.1a. I need you to work on the DOL for this lesson and the homework for this lesson. Officially, I will accept them until Saturday, but I would recommend working on them today. If you need more help, again, take a look through your textbook. There are plenty of other examples that I have left on your course page for you to try out. Again, that will tell you if you got your answers right or wrong. And if worse comes to worse and you don't finish it or understand it by today, make sure that you ask me questions tomorrow. Have a good day and best of luck.